Hi everyone, in today's lesson we're going to talk about solving quadratic equations both graphically and algebraically. So before we can solve an equation, we need to really understand what it looks like graphically. So the roots, zeros, or solutions of a quadratic equation are the x values where the graph crosses the x-axis. So if you take a look at this parabola right here, or this quadratic, it intersects the x-axis at this point here and this point here. So our roots are, we'll put them on the side here, roots, also called zeros, or solutions, are x equals -4 and x equals 2. Now you see here where it says -4, 0 and 2, 0, and that's the point. Those are called x-intercepts. So this whole point is called an x-intercept. This is very important because an x-intercept is the only type of root, if you would, that is expressed as a point. If I'm asking you for a root, a zero, or a solution, I'm asking for an x value only, where an intercept is the point itself. So please make that distinction. So this here is an x-intercept as well, where it's a point. Okay, now let's look at example number 2. We have this parabola here that crosses this x-axis here. Can you pause the video and tell me what the roots should be, and then hit resume when you're finished? Okay, your roots should be x equals 4 and x equals -3. Now, if I wanted you to write them as a point, this point would be 4, 0, and this point over here would be -3, 0. So again, what's the difference between the point and just x equals? Which is which? Again, this -3, 0 is called an x-intercept. Also here, 4, 0 is an x-intercept. And when I write it as just x equals -3 or x equals 4, that should be called a root, a zero, or a solution. So we could write that over here. These guys together are called roots, zeros, or solutions. Okay, now what did you notice about all of the y values of the points where the graph crosses the x-axis? So what did you notice about these points here, 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 and here? What did you notice about the y values of all of these points? You should be saying the y values are 0. So let's write that in. The y values equal 0. So this, the y valuing equals 0, is going to help us when we want to solve for the quadratic equations algebraically. So to find the roots of the quadratic equation algebraically, we must set the equation equal to 0, then factor, t-chart, and solve. So let's look at this first example. Is it set equal to 0? No. So we should add the 6 first, write it in order, so 2x squared minus 8x plus 6 equals 0. So we set it equal to 0, then it says we have to factor. So what is the first step of factoring that you should be thinking of? You should be saying GCF. So we're going to take out a 2, and we're left with x squared minus 4x plus 3. Now can we factor this inside a little bit more? Well, I have a trinomial here. My leading coefficient is 1, so we could just find two numbers that add to -4 that multiply to 3. So pause the video, see if you can factor it, t-chart, and solve, and then hit resume when you're finished. Okay, your answers should be x minus 3 and x minus 1 with a 2 in front. Remember, a -3 times a -3 is a +3. A -3 plus a -1 adds to a -4. So that was my factored stage, and now we're going to do a t-chart. we would do 2 equals 0, reject that, x minus 3 equals 0, add 3 to both sides, so we get x equals 3, x minus 1 equals 0, plus 1, x equals 1. So these values are my roots, or my solutions to this equation. Now, some of you may be asking, how can I check this? If you take out your calculators and you put this into the y equals, you see y equals 0, put it into the y equals, you'll see where the graph crosses the x-axis. It'll cross here and here. So if you'd like, now you could pause the video, take out your calculators, and see that that works. Okay, why don't you try example number 2 all by yourselves. So set the equation equal to 0, factor, t-chart, and solve. And then hit resume when you're finished. Okay, so you wanted to subtract 16x and add 48 to this side over here. And you should have gotten x squared minus 16x plus 48 equals 0. And when you factored it, you should have gotten x minus 12 and x minus 4. And then your t-chart is x equals positive 12 and x equals positive 4. These here are your roots. Okay, let's move on to the back. Okay, with all of these examples on the back, there's going to be a different type of factoring that you may need to use for each of these. So what I'd actually like you to do now is try these. Try 3 through 8, set them equal to 0, try to factor, t-chart, and solve, and hit resume when you're finished, and I'll give you a detailed explanation of each. Okay, so for number 3, after you set it equal to 0, you should have gotten this, 4x squared minus 36 equals 0. You should have taken out a GCF of 4, and that would leave you with x squared minus 9. And you should have recognized that this here is dots, so you should have had 4, x plus 3, x minus 3. And then set each piece equal to 0. And when you do this, 4 equals 0. That makes no sense, so you reject that. You have x equals negative 3 and x equals positive 3. Okay, number 2, when you set it equal to 0, you should have gotten 2x squared minus 50 equals 0. There was a GCF of 2. You should have been left with x squared minus 25. Again, this here is dots, so you should have gotten x plus 5, x minus 5. And t-chart, 2 equals 0 makes no sense, so you should have gotten negative 5 and positive 5. Okay, number 5, subtract the 5x, set it equal to 0. Your GCF here is x, and you're left with 2x minus 5. T-chart, x equals 0. Notice the difference between x equals 0 that you keep and the 4 and the 2's where you reject them. This is a number, so we're going to keep it. X equals 0. Then we'll do 2x minus 5 equals 0. Add 5 to both sides. 2x equals 5. So divide everything by 2. Final example, or excuse me, final answer is 5 halves. So x equals 0. And 5 halves are your roots. Alright, number 6, you should have subtracted 81 from both sides, factored using dots, x plus 9, x minus 9. 2 answers, negative 9 and positive 9. Okay, now number 7 and number 8 were a little bit harder types of factoring, because when you set it equal to 0, like you should have here, there was no way to get rid of this leading coefficient. So you actually had to factor by guess and test. So we want two numbers that multiply to negative 3. So let's just go through guess and test one more time. What do we need to do to multiply to 2x squared? Well, we need a 2x and an x. So now we want to test the factors of 3 that are going to go here and here. So I know that the only way it's going to work is if I put a 3 and a 1. So now we're going to test and guess and see if this works. So 1 times x is 1x. 2x times 3x is 6x. Now, is there any way that I can add or subtract 6x and 1x to get to this negative 1 here? And the answer is no, so it looks like that's not going to work. So let's erase this and try a different pair. So how about I put 3 here and 1 here? So I do my inners and I get 3x, and I do my outers and I get 2x. So is there any way that I'm going to get 3x and 2x to add to this negative 1? Well, you should be telling me that this negative 3, the 3 needs to be negative and the 2 needs to be positive. So negative 3, positive 2. Okay, so these are your two solutions. And now we just have to set them equal to 0 and do a t-chart. So hopefully you have an eraser and you can erase this spot down here, and we have 2x minus 3 equals 0 and x plus 1 equals 0. This left-hand side or right-hand side is pretty easy. And this one we'll have to, since I'm running out of room, add 3 and divide 2. So you should get x equals 3/2. Okay, last but not least, number 8. We needed to get everything over to one side. My suggestion, you see how this leading coefficient is negative? I don't want to deal with that leading coefficient to be negative, so I actually would bring the negative 4x squared to the other side. I would add 4x squared. So 0 equals 4x squared minus 18x plus 20. First step of factoring was there should have been a GCF of 2. And then you get 2x squared minus 9x plus 10. So again, now we can't get rid of this leading coefficient, so we're going to have to do guess and test. We want to find numbers that multiply to 10, that after we do the inners and outers, add to negative 9. So again, we're going to figure out that this needs to be 2x and x. And now we want to put the factors of 10 in here and test my outers and inners. I'm going to try 2 and 5. So let's put a 5 here and a 2 here and see what happens. So this is 5 times x, which is 5x, and 2x times 2 is 4x. Is there any way that I can get 5x and 4x to add to negative 9? You should be saying yes, they both need to be negative. So negative 4x plus negative 5x is negative 9, and negative 5 times negative 2 is positive 10. Okay, so now we just need to do a t-chart and set each piece equal to 0. So I'm just going to get rid of this for now. So we've got here and then these two. So 2 equals 0. That makes no sense, so we're going to reject that. And now we're going to do 2x minus 5 equals 0. And again, I'm running out of room, so we'll just add 5 and divide by 2. Okay. And the next one we have is x minus 2 equals 0. Add 2 to both sides, and we get x equals 2. Okay, any questions that you might have, now's a good time to jot them down, and we'll go over it in class tomorrow. All right, have a good day.